Okay, a very good evening. So I hope that I am audible to everyone. So welcome to the course that is hands-on training on QGIS. So I think you should have received the brochure and also the schedule of what are the things that we will be learning in the upcoming class. So I think am I audible? Can anyone type or hello? Okay. So let me proceed. So I will also be sharing quiz and also assignments which you should be submitting. Everything will be based on whatever is taught in the upcoming classes. So this is like a basic course. So we will be going through some of the basics of GIS. So I will be using the software QGIS. So QGIS is open source software and it is easily downloadable and it is downloadable from website. Okay, so that I will also be teaching you in tomorrow's class. So today's class is planned on introduction to GIS. So before using the software, there are few aspects which one should know before doing a GIS analysis or any other project related to that. So this course is designed in such a way that you can use this software for your upcoming projects, like your final year projects, and also you will be learning a software, so which will be helpful in your job and other areas. So these are the some of the things that we will be learning in our upcoming classes. So all the tools that are necessary for doing your project and how to do a project, and also followed by some case studies which I will be teaching you in the upcoming classes. So let's proceed with some introduction to GIS, because before going into the topic of how to use the software, there are few things which one should learn, so that how to use the how to deal with data and other things, right? So for that I will be taking today's class, and all the things that are necessary will be covered in today's class. So, a basic introduction of myself is I am Devin Ebenezer, and I am a PhD scholar at National Institute of Technology, Tiruchirappalli. So, I am a BE graduate in civil engineering and ME environmental engineering, and right now I am pursuing PhD in National Institute of Technology, and my background is environmental engineering. So, whatever some of the examples which I will be focusing will be mostly on the environment engineering aspect, but this can also be applied in other areas, like for example transportation, and also sometimes structural engineering people can also use this basic idea of how to use a software. And some of the projects which I have done is, the first one is groundwater modeling of a Sangano stream, and I have used QGIS and also visual modflow software in order to do this project. And the other one is a published work which is on the modeling of the groundwater quality in Mayiladuthurai district, and also some other things I have also worked related to circular economy. One is composting of black soldier fly of the hostel waste, and also stew white recovery from cow urine. So these are some of the projects I have worked in. So coming to introduction to geographical information system. So which is shortly called as GIS. So G is for geographical information system. So here in geographical information system, we are dealing with a geographical aspect that is connected, information that is connected with a geographical aspect. So that is why it is called as GIS. So what is GIS? GIS stands for Geographic Information System. It is a tool that connects data with a location. For example, if a particular car is there in a particular area, so a GIS helps in connecting that car with the particular location where the car is, at what latitude, what longitude, or which place a car is. So that is why it is a tool which connects a data. For example, what type of car is there in a particular area. So that is also dealt with GIS, and it is used in everyday life. For example, GIS is being used in our day-to-day life. For example, we use Google Maps, and also we order food from other Swiggy or Zomato. All things are integrated with a GIS platform. Okay, and also forecasting weather. That is also the another application of GIS. So it is used in everyday life, from Google Maps navigation to weather forecasting. And GIS can create smart maps that can analyze, visualize, and interpret spatial data. So GIS, using GIS, one can do analysis. For example, what is the time in which I will get my food? So that is a type of analysis. And also I will be able to visualize, is there any traffic in between? Is there any traffic of which I'm feeling, so that I can avoid the traffic? So that is also possible in GIS, and it helps in interpreting the spatial data, a data that is associated with the location. And also it is a key technology for solving real world problems and making a data driven decision. So using GIS, one can also solve a real world problems using a data driven, right? So in GIS, we have information. So information contains a lot of data sets, and using this data sets, I can solve a lot of problems. And I will be going through a case study how people have solved different problems using GIS. Okay. So I think my slide is visible, right? I will also be sharing the slide in WhatsApp group, and there is also a WhatsApp group that is associated with this work. So I will be sharing the WhatsApp. I will also share the WhatsApp group link um in this uh, group, so that you can also join. And also, so let me continue. So my slide is visible. My slides are visible, right? I just need a yes from you. Can anyone respond? Okay, I think it is visible. So let me proceed. So it is a key technology for solving real world problems and making a data driven decision. So getting into history of GIS. So let us get into some history aspect of how GIS has evolved to understand how GIS works. Okay, so humans have long recognized the importance and value of maps to their life. So from the beginning, people have used map to solve a lot of problems that are occurring in our society. And a brief outline and sequence of how this map making and significant developments are discussed in the upcoming slides. So there are different maps starting from 4th BC. So it is called as Sirka, and also in 15 AD, Ptolemy, and in 115, 1154 AD, Al-Idris map was developed, and in 1440 AD, printed maps have developed, and now we are coming to a modern era map. So this is an example of a Sirkar map that was developed in 4 BC. So Sirkar tablet is a part of a British museum collection. So this tablet, they got it from a Babylonian empire when it was ruling the world. Okay, so it is an excellent example of how Babylonian cartography has used signified their location of their area on a map, and also a map features such as Babylon at the center. So Babylon, you would have learned in our history, right? So it is the one of the oldest development, and Babylon was depicted at the center of the world. And here you can see the river Euphrates. Okay, so ever Euphrates is also there, which is surrounded by a mountain and encircling a ocean. So this map gives an idea of how the particular empire was. So the empire was built in between a river, and also there was lot of mountains surrounded by around the mountain, and also the other side is encircled with the ocean. So it illustrates how early civilization represented geography symbolically, not to scale. But the major problem of these maps is that since we don't have technologies to make this map into a wanted scale, so the we cannot measure the distance and other things, right? So that is a major disadvantages of this map, and these maps are not to a scale. Okay, so that is called as a Sikkar map. Then in 15 AD, Ptolemy, he's also a geographist, so and also a mathematician. So he developed this map, which is called as Ptolemy, and he was a Greek, and Romans refined the art of map making over centuries. The work reached a peak with Claudius Ptolemaeus. So his name is Claudius Ptolemaeus, who was a geographer, mathematician, and an astronomer. So around 150 AD, he published a scientific treatise titled Geographic. So treatise is like a thesis. So he has published some kind of an article or some kind of a work that is called as Geographic. And in this map, this includes thousands of reference map covering various parts of the world. So here you can see in this map, he has started with developing some kind of latitudes, some kind of a grid-based system to know the location of a particular area. So that is called as Ptolemy, and it introduces the systematic use of latitude and longitude. So he is also he was the first one to introduce latitude and longitude system in a map for better understanding of a particular location, and foundation which acts as a foundation for modern cartography. And also maps of the world that was developed in 1154 AD. So this is called as Al-Idris map. So it is called as Tabula Diogenes, was completed in 1154 AD in Sicily. So it was one of the most accurate world map for several centuries. So after this Ptolemy, 1154 AD maps were developed, and it is one of the accurate representation of that particular area. Somewhat they have tried to make this map into a scale, a proper scale. Also during this period, most European maps were produced in monasteries. So this map basically was with the people who are in monasteries, so that they are spreading where religious beliefs strongly influence cartographic design. For example, after BC, after Jesus' death, like AD or BC, there is a common practice of there was a spread of religion of Christianity in all the areas of the world. So in that time, people have developed a map, and it is a common practice was to place Jerusalem at the center of the world map. So in this type of map, people have kept Jerusalem as the center of the world map, and other states were around it. And also, many medieval European maps also showed Asia as the top, following religious symbolism rather than geographic accuracy. So again, this map is again a limitation that it is having a geographic accuracy, lack of geographic accuracy. And after that, in 1440 AD, printed maps were developed. Once the invention of printing press has been done by Johannes Gutenberg, who invented the printing press in 1440 AD, he developed a map, that is a printed version of a map that was in a paper. And at this time, the map started coming into hands of local people. Okay, map production shifted from monasteries to a broader commercial printing. Okay, and also major publishing houses emerged. So a lot of publishing people have started to publish their maps, making maps more widely accessible to the public. So initially the maps were with only few people, but once this printed map came, it came to in the hands of everyone as a printed version. And by mid 1800, printed maps became more standardized and detailed. So, as the days progressed, as the printing technology evolved, the maps became more detailed. So, a lot of detailed things were there. The places, the latitude, longitude, presence of any mountains, river streams, and all the details that are needed for a person to understand were there in a map. So, that happened in 1800 AD. Yeah, Sri Lakshmi, yes, ma'am. Uh, yeah, I think someone has raised their hand. What is the reason? Sri Lakshmi. Okay, I think it is by mistake. Okay, I will proceed with further discussion. Okay, let me proceed with further discussion. So this map became came to hands of all the people, and again this was a proper representation with respect to the scale. So here a proper scale was developed, and one can measure the distance between a particular place point to a point and other kinds of stuff. Okay, and by this mid 1800 printed map became more standardized and detailed. So it became more standardized and a detailed way so that a common layman, a common people can also understand. These maps were typically printed in a dark ink. So in those days, they printed this in a dark ink with white color, and the other color were added using by hand. For example, to represent a mountain or a river, they have painted it with different colors for a better understanding. And latitudes and longitudes were commonly included, improving the accuracy and usability of map. So in this map, both accuracy and usability of maps were obtained. And now in modern era, so in previously people were having a printed version of a map, but now everything has come into a digital way. So what is the advantage is that the maps can be a more detailed way. So here in this aspect, we can store a lot of data with particular respect to a particular location after the development of computer era. Okay. So the modern satellite advanced surveying techniques allow high precision and consistent mapping. So has the development of satellites and other technologies, so there is high precision in this case of developing this type of map, and a consistent mapping is also there. And maps today are critical tool across almost all the fields from urban planning to environmental management. So this is only limited for this type of application, but also not only limited for this type of application, but this type of map is now everywhere in our society. So the typical modern maps that was developed on 2000 onwards include a landscape and a terrain feature. And also here you can see places name, administrative boundaries, river, lakes and coastlines, roads, infrastructures and other human-made features are also represented in maps. For example, in Google Earth Pro, you can also zoom in and see the 3D structure of a building, and also you can also photos are also associated with that particular map. So many things are there. Many lot of developments are there in our modern era after the development of computer and smartphones. So from maps to GIS, from ancient maps to modern satellite mapping, humans have continuously improved how we measure, represent, and understand the Earth. So people have made different representations to understand how the Earth is. So how the Earth can be represented because Earth is a sphere. So continuous improvements have made and measurements. So people have made all these aspects to develop a. And also, while traditional maps show locations, features, they often lack the ability to analyze complex spatial relationships. Okay, while traditional maps, for example, we have seen different maps people have developed, older versions, they were often lack the ability to analyze complex and spatial relationships. And also printed version also lacks the ability to analyze because there is only a detail, but I am not able to store a data associated with a particular area. For example, if I need to store a number of people that are there in a particular location, that is not possible in the case of a printed map. But whereas in case of modern technology, when in case of smartphones and other things, people are able to store all this data into a particular database. So that is lacking in the former map. But in case of developed map, so traditional maps, this type of limitations are overcome. And the next big leap came in the year 1960 when digital technology enabled the creation of a system that could store, analyze, and visual spatial data. So in this case, in 1960s, as I was referring, in after 1960s, after the development of digital maps and also computers and smartphones, this enabled the creation of a system. So, from the beginning, we are talking about some information system, geographic information system. So, a system is created so that we could store and also analyze and visualize spatial data. So that is called as GIS, right? Geographical Information System. So the information is stored in a systematic way so that one could analyze, store, and visualize this spatial data. So this innovation, so when this innovation came, this innovation was developed by Roger Tomlinson. So this person is called as father of GIS. His name is Roger Tomlinson. He was an English Canadian geographer, the primary originator of modern geographic system. So he was a mastermind behind the development of modern geographic information system. And in 1960s, during his tenure with Ottawa-based aerial survey company, he conceptualized combining land use mapping with emerging computer technology. So before that, printed maps were there. But after the development of computers and other technologies, he combined this digital, that printed map or that map with a emerging computer technology and devised a system that is called as geographic information system. This led him to initiate, plan, and direct the development of Canadian geographical information system. So he developed a particular way of solving a problem, a particular system that is called as Canadian geographic information system. So what is geographic information system? So previously we have seen about how geographical information system, why it is, how it developed throughout the years and how it has reached, right? In 1960, Roger Thomson has developed a system which can apply for, which stands as a basis for other forms of GIS, right? So how it has evolved and how technology has helped us in developing a geographic information system so that we can visualize, analyze, and understand what is the particular scenario. And in this case, we are able to store a lot of information associated with a particular location. So now we are getting into an area that is what is geographic information system. So geographic. So geography, we have already read in our schools, right? So geography, it relates to a place on the earth surface where something is, right? We used to call or ask our friends, where on earth are you from? Something like that, right? So it relates to a place on the earth surface where something is. For example, suppose a car is there on a particular place, in which location, where this car is located, whether it is located in Chennai, whether it is located in Trichy, or whether it is located in any other place of the earth. So where this particular thing is located on the, so a particular area. So this we can represent it as latitude and longitude, right? We are representing this location in terms of a coordinate system that is called as latitude and longitude system. What is given in a location? So again, this geography is again related with what is given in a location. What is there in a location? For example, if it might be a car, it might be a bike, or it might also be a big bus that is situated there, or it might be any roadblock that is situated there. So we in this, in the geography stands for the location in which a particular thing is and what is there in that particular location. So whether the car's color is red color, whether the car has whether the car is having any problem or something like that can be stored in a particular area. What is the number plate of that particular car? So all these things are associated with this geographic location. Whereas in case of information system, this is called as attributes. So this information system helps in manipulate, summarize, query, edit, and visualize. Okay. So information system helps in manipulating the data and it helps in summarizing the data. And also if there are like 1,000 number of data, I can ask a query. For example, how many cars are red in color or whether this car is of this type, whether it is a sedan type or whether it is a hatchback type. So those type of information I can use some kind of a query language and I can ask what type of car, show me what are the locations which are having red color car or show me how many people are having hatchback type of car. So that thing is also possible and also using other tools I can also edit these values and also I will be able to visualize it in particularly in a form of a graph or any other thing. So that is what information system stands for. So your data sets are stored in a type of a way so that it can be manipulated, summarized, query, edit, and visualize. And also the other people who are using this will also be able to access this data. So it works with information stored in a computer database, right? So that is what information system stands for. So coming to the standard definition of GIS. So initially I was telling about it is a geographic information system. So what is the definition of GIS? So geographic information system is a computer based information system. So initially before that were using printed form of map, but now once the evolution of computer has happened, people are using the storing this data in a computer based information system that is designed to accept a large volume of spatial data, not only a single data, for example, not only a color of a car or type of a car, but also what is the number plate in that car, how many people are using that car, whether it is first hand or second hand. So many things are can be associated with that particular geographic location. So it is a computer based information system that is designed to accept large volume of spatial data. Okay, whatever I given example is just 5 to 6 examples, but in a particular location you can store around 200, I think more than 200 data sets that are associated with that particular location, and also that is derived from a variety of sources. So this source can be a different variety of sources, and we are dealing with lots of data, right? So this data should be efficiently stored and also it should be retrievable. Okay, not only stored but it should be efficiently retrievable, because we are dealing with lot of data. Once we have loaded the data, it should come immediately, it should not have a time lapse. Okay, it should be immediately retrievable and also analyze, it should be able to analyze and also model and display. So these data according to the user defined specification. For example, based on our query, I can ask the software to develop a particular type of graph to show what are the people, how many people are using hatchback type of car and how many people are using sedan type of car, right? So that is also possible. So geographical information system is a computer based information system that is designed to accept a large volumes of spatial data driven from a variety of sources. Okay, and to effectively efficiently store, retrieve, analyze, model and display this data according to user defined specification. So you would have wondered like what are we doing in GIS? So GIS, we are trying to bring a real world into a system, computer based database system. For example, the figure here you can see a real world. In this, we have buildings, we have a river, a playground, and homes, right? So we are having creating different layer to represent this real world scenario. For example, there is a land usage. For example, there is a one map for land usage. So here it shows a vacant ground, a river that is running, and also houses that are there. And also in another layer it consists of elevation. For example, what is the height, what is the elevation of that particular area, and also what are the passes of land that are present, and streets and customers. So all these maps combined together will form a real map. So that is our aim. So we are bringing a real world problem into a system so that we can analyze it in a better way. which is not possible in case of we cannot go there and measure or do those things in a larger scale. But when we have this different layers of map, different themes of map, we will be able to analyze on a better way, and also we can able to visualize it in a better way. So I was referring from the beginning as data and informations. So what is data and what is information? So a data itself generally differs from a information. So there is a vast difference. There is a difference between data and a information. Data is of little use unless it is transformed into a information. As I was telling, if the data is like if the car color is red color, if the car color is blue color, that is just a data. But when I use a query language to ask how many cars are there with red color or how many cars are there in green color, so that is called as information. So data is basically whatever is there in a particular site, but the information is something which one can know, common people can understand, right? So data itself is generally differ from information. Data is of a little use unless it is transformed into a information. A processed data is called as a information, right? So we are processing a data so that it is easily understandable. So that is what we call it as a information. Information is an answer to a question based on a raw data. That is what I was asking. We can ask a query in some software or GIS, and we can ask it to show how many people are using this type of car, right? So this data is now being converted into information so that we can analyze and visualize. So GIS can transform data into a information. So GIS basic idea of GIS is to transform a data into a information. So here you can see a data is needed. A data is converted by a computer into a information, and that is visible in a GIS interface. So here in this GIS stands for a software, and this software gives us a knowledge how the particular things are located in a particular situation, particular area. So this GIS, let me take you through a small case study, how people have used GIS to solve various problems that are there in our society. So GIS concepts are not new in our life, right? So it has started from this type of people have used to analyze this data in 1854. So it happened in London, a cholera epidemic in 1854. So a map for solving a problem. So in this, people have used a map to solve a problem that happened in that outbreak that happened in London. So that is a small case study that happened in 1854. So Dr. John Snow used mapping in 1854 to identify a source of cholera outbreak in London. So in 1984, there was a lot of cholera outbreak that was happening in the London city. Okay, so people were thinking what might be the reason behind this type of cholera outbreak. So in that case, Dr. John Snow, a doctor, okay, a medical doctor, he used a map to solve this issue. So what he did was he created a map showing the locations of cholera deaths that are there at the society. Okay, so he created a map something like this, and here you can see a bar graph that are shown here. So how many people are affected with cholera or how many deaths happened in this particular location. So in every street he has created some kind of collected the data, and he have plotted there in the streets. Okay, so these are all bar graphs that are shown here. So what he did, he created a map showing the locations of cholera death. And by analyzing the map, he noticed the pattern of polarized death. So what he did, he collected the data and he plotted the data in this particular map. So that is now it is in the phase of a data stage, right? So now he has started to analyze. So he by analyzing this map, he noticed patterns of cholera death. So this investigation pinpointed the source of an outbreak of a contaminated water pump. So using this particular map, he found out that there is a contaminated pump that is located in this nearby location. Here you can see the cholera deaths are lower in these areas, but it is too much in this area. A lot of deaths happened in this area. So he finally concluded that there must be some type of a contaminated well that must be there in this particular area, which is the reason for this cholera death. So in this investigations pinpointed the source of the outbreak, that is a contaminated water pump that is there in that particular society. Though not a cartographer, he considered a pioneer of disease mapping and epidemiology. So what he did, he plotted and he found the reason for this cholera outbreak. Here you can see there is a contaminated well that is there located in this particular area, and because of this, people were using water from this pump and they were drinking it. So as we already know that cholera is spreading through water. So people had drank this water and they got infected. So now he has collected the data from that particular area, he plotted it in a map, and then he analyzed the map, and now he was able to pinpoint the problem that is located with this particular outbreak. So as I was telling, he was a medical doctor, but though he was not a cartographer, he was considered a pioneer of disease mapping and epidemiology. So he demonstrated that geographical mapping allows analysis of spatial data to find patterns. Okay, so he demonstrated that this using this geographical maps, using the data that is collected associated with a geographical map, we can also analyze and solve a lot of problems. Even before GIS exists, mapping helped ask questions and solve real world problems just like modern GIS. So this same principle is what we are applying in our real world problem to solve our real world scenarios. So coming to the applications of GIS. So because to make this course more interesting, if we know what are the applications of this GIS, that will be a better one. So if GIS is applied in educational, for example, mapping of school, how many schools are there in a particular locality, followed by whether the school has a good infrastructure, nearest college is there, whether a school is there with respect to a particular area. So that is one type of application, and also health. For example, if there is any medical emergency, what is the location of a particular hospital? So that is also one other application of the health. And also John Snow study is also a typical example of how GIS can solve health-based problems, health associated problems to solve a real world problems. And also insurance, for example, if there is a cyclone that is passing by, what are the areas that are affected by this particular cyclone, what are the how homes that are affected by this particular cyclone. So that is also can be solved using this type of GIS maps. And also manufacturing industries, for example, if I'm constructing some kind of a house, okay, if I'm doing constructing some house, so I can also think about whether from where I should bring the raw material, whether it should be whether I should bring it from a long distance place, or can I open outsource from locally available people. So something like that is also possible, that is with respect to house and also other industries. Okay, so that can also help in cost cutting for industries. And also, for example, constructions, like as I was discussing, the raw materials for this construction industry, like highways, homes, construction activities, can also be solved using this type of GIS software, that is geographical information system. And also real estate, for example, different properties, I can also solve a lot of real estate's problem, like people have now started linking the documents of a particular location. For example, if someone who needs to buy a particular land, so that number and other things are associated, documentation work is also associated with that particular location. So using GIS, I can also have an idea whether that particular location is good, whether that particular location has any problem or something like that. So it can also solve real estate problem, that is for the buying of different properties, land far from station, whether the particular location is far away from a station or a school or something like that is also possible. And also retail, for example, now we are using many delivery things, right? Blinkit and other stuffs. So retail problems like shopping mall, delivery, retail, those problems can also be solved using this GIS, geographic information system. And also public safety, for example, disaster management, emergency response, and also one other important thing is sustainability. For example, forecasting the forest cover. So for example, if I need to plan for a development of a road, I can also find what are the areas that need forest cutting, or whether there is any reduction in the forest cover, forest fire. The real-time monitor of GIS system helps in understanding the forest fire, and also forest survey is also possible because we cannot access it using a normal way. But now, as the development of satellites and other things are there, that is also possible. And also telecommunication system, that is planning different telecommunication towers that are there in a particular society, that is also possible for, that is also be can be solved using GIS system. GIS. And also water. As I'm from a water environmental engineering background, I can also say that GIS can help in solving a lot of water related problems that are like drinking water problems. For example, in many places that are there in Krishnagiri and other places that are affected by fluorides that are present in water. So I can see using a GIS, I can also able to visualize how these fluorides have contaminated the particular area, whether people can use groundwater for drinking or whether I should plan any other kind of alternate source. So that type of water problem is also there. And also in case of water, again, I can say that we can analyze lot of parameters that are affecting our water, groundwater and other things is also possible, that can be visualized and analyzed using GIS. And also government bodies are also using GIS, and we can say that they are the first user of GIS, and they can see plan and governance on its regional aspects. And also utilities, for example, planning of water utilities, electrical lines can also be solved using GIS. And transportation problem, for example, if I'm going for paving a road, how to connect different cities, how to connect different places, that is also can be solved using a GIS software system. And again, conservation of natural resources, how much forest is there, whether any animals that are living in this particular area that is of endangered species. So this can also be visualized using this GIS. So natural resources, how forest is there and saving the natural resources, those are also aspects of solving the GIS problems in our day-to-day life. So coming to what are the career paths and opportunities that are there in this area. So here you can see market size of Indian GIS industry is projected to reach 2,912 crores by 2026. So this area, there is the work on this area is also increasing, and the job opportunities in this area is also increasing. And okay, sir, could you brief on contamination of water due to fluoride, sir? Like, is it possible to track fluoride's content due to relying on GIS? Again, the problem is like with GIS is we have data sets. We will take data sets in a particular distance, different areas. So from that, we will do some kind of a interpolation, and we will be able to get a visualized area of that particular thing. Okay, so interpolation will also have some type of error. So we have to decrease the sampling locations in order to understand what are the areas that are affected with fluorides. But again, whatever contamination due to fluorides, like is it possible to track fluoride contents? Just GIS is just a software on how the extent of that particular fluoride is there. But in order to track, for example, are you referring to how the fluoride is transported in water, something like that, or anything else you are asking? Yeah, fluoride. Fluoride, normally what will happen is fluoride is mostly due to geographical like rocks that are present in the in groundwater. So that is the major reason for this type of fluoride that is occurring. But for example, in case of total solids or any other heavy metals, we can use some kind of software. I was telling that visual mod flow or some kind of groundwater modeling software in order to track this type of transport, how this particular heavy metal transport is happening in or in under the groundwater. So that is a software that is available, but for that you should have a background that is GIS, because that software will give you some kind of output. So in order to visualize it in a better way, GIS will help you in that. And also there are also some engines that are there inside the GIS that will also sometimes can help in simulate this particular type of tracking, how the particle is traveling in the groundwater, whether this contamination has reached from this place to the other location. So that is also possible. And also there are not only software, you can also use Python programming, and maybe an R programming is also there to simulate how this transport particular transport is affecting or how this is happening. So for that you need some kind of equations that you need to understand and build based on that. So that is what your answer is. Any other doubts? So I think I'm clear, but you can also explore on other softwares, that is Visual Mod Flow, and also another software is also there. Fee Flow is also there, and another one QMS or something is there. I don't GSM, that is also there. So those software can help you in tracking how a particular contaminant is traveling from a particular place to the other. So I think you can make a note of that. So that is what, in order to simulate that, you need a data set. You will be giving some kind of data into this as an input to in this software. For that, you need GIS. So because you need to give the reference system and other things. So for that aspect, you need GIS, and that is what my answer is. So I think we will proceed with the next one. So the market size of this GIS is GIS and GIS related industry is increasing, and the growth will be in development of smart cities. I think people have started. You have heard about smart cities. Different smart cities are developing. For example, Chennai is a smart city, and also Smart City Chennai program, and also Smart City Kovai is also there. And also people are using it in urban planning, transportation, logistics, and increased demand of spatial data across India. Since we are going in a very fast development phase, we need a GIS planners for in our future to build our society. And in the fields like this is not only the application, in the fields like hydrology, urban planning, environmental engineering, etc., GIS has become important part. For example, as an environmental engineer, I am using GIS in various aspects. So it is finding application in all the areas. So that is a career opportunities that are there in GIS. So there is a code that is, you can build a house in AutoCAD. So as a civil engineer, we draw a house, we plan a house and do many other things in an AutoCAD. But you can build a whole country in GIS. So if you need to build a better world for everyone, GIS is needed. So thus that is end of part one. And now we are going into the concepts of GIS, which is of very important. Whatever we have learned till now is basic, but now is important. Like we need to understand different things that are there in GIS so that we could use GIS properly. So till now, you have any other doubt, or should can I proceed? Can I proceed? Okay, let me proceed with the next part, that is that are different components that are there in GIS, and also different data sets that are there and other things. So components of GIS. So from the beginning, we were talking about information and methods to store this data, and how we are going to store this data, and how we are going to analyze this data. So that is where the component of GIS comes into play. So in order to have a GIS system, a geographic information system, and in order to analyze it, we'll be needing a hardware, a software, a data, people, and methods. Okay, so here you can see we need a hardware. For example, it is a computer. So computer, it can be in terms of a computer server or a smart device, for example a smartphone which we are using, which operates a GIS or atmosphere, right? For example, Google Map. So Google Map is also for example, in order to run a Google Map, we need a smartphone. So that is what we call it as hardware. It might be in form of a computer, a server, or a smart device. Okay. And next one is a software. In order to store this data properly, and also in order to retrieve this data properly, in order to analyze this data properly, we need a software. So for example, it is a key GIS tool and applications often supported by a database management system. So as I was referring, here we are dealing it with thousands of data, millions of data. So in order to store this data, we need a proper database management system, which is shortly called as database DBMS. Okay, so proper database management system is needed, and this data needs to be stored in a proper hardware, a hardware which can help in storing this data. And also coming to data, so in order to have a GIS, we need a data set. So it integrates spatial, that is a location based data, with other attribute data source. So data is like I was referring, like for example, if there is a color of a car, or a whether what type of car I'm having, that is data. So that data is needed for a GIS system. And also people. So if all these things are there, there should be some person who should be able to analyze it, right? So in this aspect, we need people. So that is GIS managers, analysts, technical specialists who perform everyday operation. So how we can operate with this data, how to analyze this data, how to interpret this data. So that is called as people. One of the component, one of the other component of GIS is people. And coming to the fifth one, that is methods. We need to have a formalized and proper method in order to develop or get this data. So these methods refer to it is a well-defined operational procedures and strategies for effective GIS use. For example, if a person A is working on GIS and he has stopped from work, so a new person is appointed. So in order to get the same data, in order to get the same information, we need to have a particular methods that are associated with a particular industry. So that is called as a well-defined operational procedures. For example, standard operating procedures are there given by a different industries, right? So these methods are needed to have a proper analysis and proper understanding and proper retrieval of data. So methods are also very important aspects of GIS. So it is a well-defined operational procedure and strategies for effective GIS use. For example, if I'm getting information, if I'm using a data and interpreting something in Chennai, the same thing a person sitting at Trichy should also get, right? So that is why we need a proper method on how to access this data and how to retrieve this data and how to analyze this data. So that is also the one other major component of GIS. So GIS consists of 5 components. There are also other thing components, but major components are hardware, software, data, people, and methods, of which people are the people who are analyzing and interpreting the data. So coming to the data, because GIS is connected with data, so there are two types of data, that is thematic layer and that is one is spatial component and non-spatial component data. Okay, so thematic layers and data sets. So GIS organizes geographical data into a series of thematical layer and tables. Okay, so previously we have seen like different layers, like for example a land use layer was there, and whether how many customers are there in the previous slide, right? So these are the thematic layers. Maybe I will take you to that. So here you can see different theme layers, right? So one layer was associated with land usage, and the other layer was associated with elevation, parcel, street, and customers. So these are thematic layers, and this layer consists is associated with a table. For example, how many houses are there in that particular location, how many people are there in that particular location. So all these things are stored as a table. Okay, so we are having two types of data. One is thematic layers and tables. And also, what are the two types of data? One is spatial component, that is where it is, that is geographical location on which where this particular thing is, right? So where it is. And also non-spatial data, that is thematic component, what it is. Okay, so for example, if a car is there in a particular location, it is there in 12-degree north, 13-degree east, or something like that. Whereas in case of non-spatial component, like what is the color of car, whether the car is of this company make, whether this is bought in 2019 or 18. So something kind of data is associated. So there are two main types of data. The first one is spatial component in that particular data area, and also a non-spatial component and what it is, where it is and what it is. So this data sets can be divided into two types. One is spatial and non-spatial data, right? So the spatial data consists of a vector, raster and tin, and whereas non-spatial data also contains different classifications. So the spatial data is where it is and non-spatial data is what it is. Okay. So spatial data consists of three types. There are also various other types, but these are some of the important data sets that are there. So vector data consists of a point, line, polygon, and a raster data consists of a grid and image, and TIN. TIN stands for triangular irregular network. Whereas in case of non-spatial data consists of nominal or categories, ordinal or ranks, interval, ratio, cyclic, counts, and amounts. So I'll be also telling what are these types of data. So what is a vector? So in our physics, we have learned that vector is something that has both magnitude and direction. So similar way, vector data allows the user to specify spatial locations and assume that geographical space is continuous, not broken up into a discrete grid squares. Okay, so a vector data is a spatial location. So this is also associated with the spatial locations and assumes that geographical space is a continuous. So vector data is continuous and it is not broken. For example, in case of raster data, the data sets are broken. Here you can see pixels, right? So these are pixels, but whereas in case of a vector, for example, this square here is not broken, right? So it assumes that it is a continuous data, whereas in case of no, raster data, that is not continuous. I will be also telling raster data, so you can just understand right now. So vector data allows the user to specify spatial locations and assumes that geographical space is continuous. But whereas in case of raster, the geographical space is not continuous and not broken. Okay, into a discrete and grid squares. So pixels are divided into a grids. But in case of vector data, it is not like that. So it consists of the vector data can be classified into points, lines or polylines and polygon. Okay, like how we use in geometry. We have points, we have lines or polygons and polylines. And I was referring that this data is vector is like having both magnitude and direction. Similarly, this this lines and polygons will also have magnitude and direction. So that is why it is called as a vector data. So it stores features such as x and y coordinate pairs, and sometimes it can also include z values of height to correctly locate itself in a 3D space. So in this vector data is stored as a x y coordinate, and also some cases it will also have a z value, that is to represent the height correctly located itself in a 3D space. So one such example of a vector data is a point. So it is a zero-dimensional abstraction of an object represented by a single xy coordinate. For example, in a geometry, you will draw in a graph, we will draw a point. So that point will have a xy coordinate. So that is what a point is in a GIS. So it can normally represent a geographical feature that is too small to be displayed as a linear or an area. For example, Chennai is a city, right? So Chennai has a very large cover of land area as a city. But while representing that in a map, that is represented as a point. So that is where we apply a point. It can normally represent a geographical feature too small to be displayed as a linear or an area. For example, in case of a world map, if I need to represent Chennai, I will be using representing it as a point. So that is where the use of a point data comes in. Okay, for example, these are some of the points that are located in a particular location. So that is one type of spatial data. And also other type is, another one is line. So next type of data is line data. So line is the simplest one-dimensional straight line between a, when we connect 2 points, the line comes, right? So it is the simplest one-dimensional straight line between 2 points or a polyline. So when two to three lines or more than two lines get connected, it is called as a polyline. And when they are more than 2 points, so here you can see there is 1 point over here, 2 point, 3 point, and 4 points. So many points can also be there in case of our lines. So they have both magnitude, that is length, and direction. So this helps in doing a lot of analysis, which we will be discussing. For example, if I'm finding a stream from a particular location, so in that the direction of the stream is important, and the width of the stream is also important. So that is where the line application comes in. So here you can see how people are using lines to represent the streams that are there. So for example, bigger streams, sorry, smaller tributaries will join to form a stream, and that will finally get end up in a larger rivers, right? So that is where the application of line comes in. And also roads, if there is a road that is coming from a particular city to another city, so how the road is connected, whether the road is of first order or whether the road is of second order, that is like whether the road is of national highway or whether the road is state highway. So that is what I was referring as first order and second order. So as I said, it has both a magnitude and also a direction. And coming to polygons. So what is a polygon? It is used to represent areas and is fully encompassed by a series of a connected line. So when these lines are connected together, a polygon comes. So it is used to represent an area. Okay. So here you can see a location of a particular river or a particular continent or particular land that is there. So that can be represented in terms of a polygon. So this will also we will be using in GIS, and it consists of a line that makes up a boundary. So when we form a polygon, it shows a boundary. For example, this is a location of India. This is a location of Pakistan. So this boundary is Pakistan, or this boundary is India. So that kind of representation can also be done using polygon. And also it can determine the area that falls within this line comprising the polygon. Okay. So this is one type of data. I was telling about spatial data, that is we have completed vector data. Vector data consists of point, line or polyline, and also polygon. Okay, this is this as the major assumption of this vector data is it is a it assumes that everything is continuous and it is not gridded form of data, right? So this will also be it will be helpful in GIS when we do a lot of applications. So the next one is raster, that is grid and image data, image data set. So what is a raster? Like for example, if you take a photo and if keep on zooming, we can see a lot of pixels that are happening there, right? So that is a typical example of a raster data. So it stores the image as a rows and columns of numbers with a digital value. For example, in case of your photo, there is a color code, right? In a similar way, in case of this raster file, that each grid, each cubes, right? Each cube here will carry some kind of a value. So that is what we call it as a data, digital value. So it stores the image as a rows and columns. For example, the data is stored as a number of rows like 19 rows and 19 columns. So it stores an image as a rows or columns of numbers with a digital value, and data is classified as continuous. Okay, in that case, okay, I think it is non-continuous, such as an image where values vary smoothly across space. Example, elevation or temperature, or thematic, where each cell denotes a feature type of category. Example, land use or a soil type. For example, this map, this is a vector type of example. So this map has been, sorry. Okay. So when I convert this type of map, what happens is it just converted into a vector format. That is a raster format. This vector data, this vector map representation has now been converted into a raster format. And here you can see this all the white boxes, white cubes, white squares represent the ocean or other places, and the blue thing, the blue boxes represent the river, and the trees that are there is also represented in this raster file as a box. And also house, you can see that is also represented as a small square area. So that is how when you convert vector data into raster data, here you can see some errors that are happening. So in order to decrease this error, what I can do, I can reduce the grid size. So that is one other data. And also numerous data formats are also available to store this type of raster data. For example, it can be stored as TIFF, or images can also be stored as TIFF, right? So this type of TIFF file and GIF file and EDRAS, etc. So the shape of all the raster models can either be rectangular or square. So this raster data can either be in form of rectangle or a square. If it is irregular, what will happen? The data sets other places will be assumed as zero. So that is why we call it as it is either a rectangle or a square. I think someone is raising the hand. How? What is the question? Do you have any doubt? Okay, I think I'll be finishing in some 10 minutes, and we can have some discussion after that. So you can be ready with your questions once the session is over so that we can discuss. Right? Can I proceed? Okay. Okay. So in this case, it can be stored, it is usually in terms of rectangle or a square. And if the data is not there, that grid will be assigned as zero. So for example, in case of image and grid, the each unit is called as a pixel, and in case of a grid, it is called as a cell. And in values, in case of image, can only be a positive integer, whereas in case of a grid, it can be both positive and negative integers, and it should be a real number. So the clarity of this image or grid is decided by its spatial resolution. For example, I have shown three different images. So in the case of first one, so the grid consists of 1 meter by 1 meter grid boxes. Okay, so this is having a better information when compared to 30 meters, right? This is the more details are there. For example, there is a water body that is going in this direction in here, but whereas in case of 30 meter, the resolution is not good and I'm not able to visualize it properly. So here in case of a raster, the resolution is one of the major important point that should be noted. So whenever if I'm starting a project, the resolution of the data is one of the major important factor, because if I'm working on a very smaller area, the resolution should be higher. Okay, but if I'm working on a larger space, for example, if I'm working on a whole world map, I need a smaller resolution map. A 30 meter by 30 meter will be sufficient. But if I'm working on a place like Chennai, a small area, for example, if I'm finding any effect of air pollution or effect of water in that particular area, in that case, I need a grid system that is of very lesser, higher resolution. For example, 1 meter by 1 meter will be okay. Okay, so that is the one other aspect that should be noted in case of a raster file. So here you can see how a raster image is there. So in this case of raster image, here you can see the boundaries are not distinct, right? So I cannot show this raster image for a boundary map of India, right? So we cannot visualize how where the location of whether this place belongs to a different country or something like that. But when I use a vector representation, that will show the boundary more properly, right? So both things have major both advantages and disadvantages, which you will understand when we do we work on different maps, okay, in the software. For example, a point feature here is represented as a small point, but when it has been converted into a raster format, so the whole square has been occupied. So it means that the whole square is of that particular point. But that is not the case, right? So it is a small point, but here it is represented as a bigger one. And again, for example, a river that is flowing. Again, the river, the boundaries, the path of the river is well visible in case of a vector file, but in case of a raster file, this river is not shown properly. But again, in order to increase this resolution, we can increase the resolution and do the problems. So that is also one case. And also here you can see a polygon. So polygon is shown here as a vector format, but when it has been converted into a raster format, the boundaries are again not distinct. So that is one other advantage and disadvantage of a raster and a vector file. For example, we will see what is the advantage and what the comparison between vector data and also a raster structure. So in case of a vector structure, the data is complex, okay, because I have said, right, the line has both magnitude and the direction. For example, if I'm drawing a particular line in a particular GIS, that line will have the direction, the line will store the direction in which I'm drawing the line. Okay, so that is why it is called as a complex. So for example, if I'm trying to intersect that line, that will not happen. So that is why we call this particular vector structure as a complex. But in case of a raster structure, it is simple. Okay, each grid will have a particular value. And also position of precision can be precise and that's accurate. For example, in this case of a boundary, the boundaries are more clear in case of a vector file when compared to a raster file. Okay, so again, this is limited in case of a raster file, it is limited by a pixel size and also attribute precision. Okay, it is good for a polygon, point, line data, not good for a continuous data. Okay, in case of a vector data, it is good for a polygon, point, and line data, but in case of a continuous data, this vector representation is not good. Whereas in case of raster file, it is good for a continuous data. And also comprehensiveness of analysis and capability, good was good for spatial query and relative simple data analysis limited to intersection. For example, in GIS, if I'm having a vector file, I can just get the area just by giving a command like finding the geometry of that particular thing, and it will give me the area, the perimeter, and length of the arc, and other things will be there. So that is possible in case of a vector structure, but it is not good for a spatial query, but very good for spatial analysis, filtering, and modeling. So that is also one other application. And overlay ability. For example, in real world problems, what I will do, I will try to overlay one map over the other. For example, in order to find water quality index of a particular area, so how the water quality is there in a particular area, what I will do, I will overlay one map over the other to understand how the particular water quality is there. So I will develop an index. In that case, vector doesn't work well, but in case of raster, it works well. Good, but overlaying may cause splinters in case of vector data, but in case of raster data, overlay procedure do not create a problems. And storage part is, though the vector is small, but it is complex. Okay, so I explained why it is complex. And in case of a raster, in this, it depends on the pixel size, and it is large and simple but may be complex sometimes. And also conversion is simple to do, but converting a raster to vector is difficult and quite often creates wrapped images. For example, if I convert this vector data to a raster, conversion is good. But again, when I convert this raster to a vector, the boundaries are not will not be again produced, right? So there will be particular deformed boundaries that will happening. So that is also not possible, not properly done with case of raster structure. And also in case of a output map, it is, excuse me, in case of a output map, it is very good. In case of vector structure, it is very good and looks like a map. But in case of a raster structure, it is poor and doesn't look like a map to a lay people. So that is the advantage and a comparison of raster and vector structure. So coming to the triangular irregular network, it is a surface representation derived from a irregular space points and break lines. So in this, what are we trying to do? We are dividing this particular area into a triangular irregular networks, and each sample points have x and y coordinates and z values or surface value. So it has x and y coordinate and also a z value that will represent the elevation. It represents a surface as a set of continuous and non-overlapping triangles with each triangle surface is represented by a plane. So here you can see a typical example of what is triangular irregular network. So this particular surface is now shown is represented as a triangular network. Okay, so this consists of a triangular vertex, triangular face, and triangular edge and other things. So the I think my pointer is visible there. So in this image, you can see the first one is a triangular irregular network, whereas the other next one is raster data. Okay, so in this one, uh, uh, in this one here, you can see a particular square location has 1, 2, 3, 4, 5 points. But whereas in case of a raster, it has only 4 edges, right? In this one, it is having more edges. So in case of a triangular irregular network, the data required is more. The storage space required is more when compared to the raster file. Okay. For the advantages is that for areas with complex relief, tin works better than a raster. For example, if there is a space with lot of ups and downs, lot of drift, other things are there, it is good for this particular area. Again, it depends on the place, whether you should use for triangular irregular network or whether we should go for a raster data. It provides a more detailed representation for high density of data points. As I said before, when I consider this particular box a square, here you can see I have 5 particular data, like one vertex is also there, right? One edge of a triangle is also represented here. But in case of a raster, only 4 points are there. And also breakpoint features more accurate. Example, ridge line and valleys are more better represented in case of a triangular irregular network. And the major disadvantage of this triangular irregular network is this significantly more processing, significantly takes a lot of processing time to generate the triangular irregular network, because I said there are a lot of data points that are associated with this particular triangular irregular network. So that is end of spatial data. Now coming to the last data type, that is non-spatial data, that is called as attribute. So we initially now we have dealt like where it is, and now we are going to deal what it is, right? So where it is associated with a particular x and y and z coordinate, but in case of attribute, it is stored as a table. That is what it is. What is the attribute of a particular person? What is the attribute of a particular area? So that is what we are now going to discuss. So each geographical features has one or more attributes that identify what the feature is, and it describes it or represents some magnitude associated with the feature. So the analysis depends partly on the type of attributes are being used. 6 kinds of basic attributes are used in GIS. For example, this attribute is like, for example, I was referring, right? For example, a car, whether the car is, what type of car it is, whether the car type is hatchback, or whether the number plate is of this registration or that registration, or whether it is owned by this particular owner, whether it is owned by this particular owner who's placed in this particular area. So that type of data is called as an attribute data. So this type of data consists of 6 kinds of basic attribute data. One is called as nominal or categorical data, and the next one is ordinal or ranks, intervals, ration, cyclic, counts, and amounts. So, in case of a nominal, that is categorical data, it represents a name. For example, if the car color is red color, that will be coming under a nominal data that represents the name or categories with no numeric meaning. In this case, nominal data, there is no numerical meaning associated with that particular thing. For example, a land use type. For example, whether the land is of construction purpose, or whether the land is a forest, or whether the land is a barren land. So that is called as a nominal data. A forest name, a place name, house name, driving license number. So all these categories comes under a nominal data. So the next type of data is a ordinal data, that is a ranked data. Okay, it shows the order or ranking but difference between ranks are of not uniform. For example, stream order, right? I was referring like a road that is coming from national highway and just diverging into a state highway. So this is called as first order, second order, and third order things. So similarly, a tributary will again form a bigger stream, and stream will form a river. So that comes under ordinal data. In this case, the difference between the first and second order is not equal, right? So stream order, that is first, second, and third order, and also educational levels, case of primary and secondary. So we cannot say that primary, secondary is two times of primary, right? So that is not accordance with this particular thing. So it shows order or ranking, but difference between ranks are not uniform because primary is different and secondary is different. So this type of data is stored in such a manner. Okay, this is again an example like stream order, the road that is diverging, and also educational level in a particular area. Excuse me. So that is called as a ordinal, that is a ranked data. And another one is interval data. The number shows how much or how less something is, but there is no real zero. It doesn't mean nothing. For example, a temperature that is there in a particular place, a temperature in a Celsius. The gap between 10 degree and 20 degree might be same, but zero doesn't mean that no temperature. For example, 0 degree, there is some kind of hotness that is there, but it is very cold, right? So some kind of relationship, that type of relationship is called as an interval data. So for example, is temperature in Celsius, the gap between 10 degrees Celsius and 20 degree is the same as between 20 degree and 30 degree Celsius, but 0 degree doesn't mean no temperature is there, it is just marks freezing point. Okay, so this type of data is called as interval data. And also coming to a ratio data, it is also same as the interval data, but with a true zero point. In case of the interval data, there is no true zero point, but in case of ratio data, there is a true zero point, meaning absence of a quantity. For example, a population, so the population might be zero in a particular place, and also a distance might be zero, a rainfall might be zero, and area. So this is called as a ratio data. And the fifth one is directional or a cyclic data. So it represents angles or directions where values repeat cyclically. For example, degrees, for example, 0 degree and 360 degree indicate the same direction, but again, it is a cyclic data. So it is shown as a degrees, right? So it is called as a directional or a cyclic data. And also counts and amounts. It represents a measurable quantity that can be counted or totalated, and number of students in a class, number of trees in a forest or a house and a village. So that is another type of data. That is counts and amounts. So there are six types of data. One is nominal data, ordinal data, interval data, ratio data, directional, and also counts and amounts. I think that is end of different types of data that are associated with it. So today's class we have seen about what is GIS, and also how what are the different areas where the GIS is being applied, and also we have seen about different data sets in GIS, different data sets that are there in GIS, like for example spatial, which is where particular thing is, and also non-spatial data that is called as attribute, that is what is there in a particular place. So that is about today's class. I think with that, uh, that is the end of today's class. So I think you have some doubts, you can ask now. Now it's a time to ask your doubts. You can also type in the chat box. you can ask. I will also share my mail ID. I think you people can join a WhatsApp group so that I will also be sending you the assignments and also quiz questions which you need to answer. So I'll be sharing it on Wednesday. It's coming Wednesday. So tomorrow's class, we will be looking into how to install GIS software. So be ready with your computers. And also I will be, once that is done, I will also be showing the interface on how or what are the different things that are there in the interface. So that is also there. So I think someone was having some question, but they are not asking now. You can ask now if you want. I'll wait for another 5 minutes. So I will also share this video uh, so that you can also have a look. And also I will share the PPT presentation uh, for your reference. That is, I will be doing that after tomorrow's class. Any doubt till now, or is there anything you want to learn in terms of GIS, whether any other application you people are working on, or any other project ideas which you are having to where you can use GIS to solve this problem, so that I can also try on that and also stress on that while doing the other classes. So that also you can specify right now, so that I can also come prepared in coming classes. No other doubts? Can I close the session? Okay, we will close this session and I thank everyone for joining. So tomorrow's class will be from 4 to 6, which is as per schedule. So be prepared, make sure that you have a good laptop so that we can see how to install the software and also graphical that is graphical interface of that particular GIS software. So there are a lot of YouTube videos that are also available on how to install it. But again, I will be teaching on how to how to install the software, and followed by a small introduction on the graphical interface. And in the upcoming classes, like from next week, we will be delving into different aspects on how to use different tools in GIS. and also some other applications. People have also asked how it can be used in urban planning and other things. So I will also add that. And also, in order to use GIS, I will also give you how I use GIS, right? So how I use different softwares to bring the things from one software to the other. For example, how I'm using Google Earth Pro and where am I downloading many datas, where I can get data. So those things also I'll be explaining in the upcoming class. And also maybe I will also have one more session, maybe some kind of AI application and also how data science can be helpful in solving these types of problems. So I think we will close today's session. So I thank everyone for attending. So I will also be sharing the feedback form tomorrow that you can also fill it so that I can improve my lecture and other things. And also I can be more specific on whatever people are needing. So with this, we will close this session. Thank you.